My name is Brian Olson. I'm the mechanical work group lead for the Anchorage office. I've been working for Anvil for a little over 20 years now. I've worked in both the Billings, Montana office and now in the Anchorage office. And today I'm going to be discussing how to extend the life of pressurized equipment and piping and avoid unplanned outages with fitness for service assessments. So part of this presentation will go over the who, what, when, where, why, and how of fitness for service assessments using API 579. And we'll run through a few examples of past projects where we've assisted. And then we'll wrap it up with any questions you may have. So what is a fitness for service assessment? So the goal of a fitness for service is to perform engineering evaluations with quantitative results to prove the structural integrity of a component or piece of equipment that contains a flaw or damage that is beyond the original design corrosion allowance. The main objective is to come to a decision point to either run it as is, to repair it, or to alter it, or re-rate it, or replace it if you have to. So the main document that we use for fitness for service is the API 579, as you can see on the right side of the screen there. That's a whole printout from API 579 that shows the damage classes it addresses, and that breaks it down into individual parts that you can use to assess that damage. Typically, when we're doing a fitness for service assessment, it's more reactive in nature. So say an inspection has found some general corrosion or erosion or a cracked pipe flaw or something like that, we're going to be reacting to that. But you can also use it proactively. We can use it to do like creep or fatigue reviews. We can use it to provide flaw sizing guidelines for future inspections, or we can use it as a brittle fracture screening tool, which can be important for vessels built prior to 1987. Anvil has experience with almost all of these parts of API 579 and completing assessments. So there are a number of reasons to perform an assessment, some of which are extending the life of your piece of equipment, allowing you to plan and budget for a future replacement, or avoiding the cost of an unplanned shutdown. You can also possibly eliminate the risk of doing a repair that's not necessary. But you can also use it to improve the efficiency of your maintenance and inspection programs. One way is by understanding the damage tolerance that a piece of equipment can have, you can integrate that into your risk-based inspection program, or you could possibly reduce or eliminate costly inspections that aren't necessary. Like in the end, the main goal of everyone is to ensure the safe and reliable operation of your aging equipment. So if a fitness for service needs to be conducted, there are a number of people that should be involved in that process. From an engineering standpoint, Anvil can provide the mechanical engineering, structural and process engineering, as well as metallurgical insight. However, to properly do an assessment, it takes additional people. So the owner user and their operations group should have input, and then the inspectors that are involved. So of course, Anvil can help facilitate all that. So each part of an API 579 provides different assessment techniques, and within each technique, it's broken down into 3 levels. Each level has a acceptance criteria that correlates to that level. So you can see on the right side of the screen, goes from level 1 to level 3, with level 1 being the most simple, most conservative approach. It's low time sink, low cost, and can typically be done in-house or by an inspector. Level 2 jumps to a little more detailed analysis and evaluation. The inspection techniques usually aren't that much greater than level 1. But that level is completed by an engineer, and then level 3 is the most rigorous and will typically require an FBA to be completed. Normally, you'll start with a level 1 and work your way up until the result is obtained that you're looking for. So now we'll jump into a few examples of other projects we've worked on and the different damage types. So this first one is a general corrosion assessment example. This particular tower was located at a natural gas facility. During a standard API 510 external inspection, they found a locally thinned area. So they came to us to quickly assess it to see if they needed to shut down to repair it or if they could make it till their next turnaround. So the first part of the assessment is to understand the damage mechanism. In this case, they had recently, within the last couple of years, increased the throughput in the unit. So this was directly across from the inlet nozzle so that higher throughput created a higher velocity and created some impingement damage opposite of the tower. So with knowing the damage mechanism, we were able to start the assessment. In this particular case, derating to a lower pressure to help gain corrosion allowance was not an option. So we looked at a level 2 assessment. And by doing that, we had to coordinate with the inspection crew to have them do a UT grid to allow us to find the critical thickness profile in that locally thinned area. So after doing that, we were able to prove with the level 2 that the vessel was acceptable as is. And then with the pretty well-defined damage rate, we came up with a remaining life in excess of 14 months, which got them past their next shutdown. So that was good on our part to help them out there. And then we also helped them out with a repair plan, which included a flush patch repair. And then we also added an inlet device to remove that future damage. So the next example is a fitting assessment evaluation. So this particular vessel with an LPG bullet that had originally had an insulation that was like a mastic type that also was used as fireproofing. During a normal installation, by looking through the plug holes, you could see that there was some pitting starting to happen. So the client completely stripped the vessel to see the extent of the damage. And as you can see in that top left photo, the majority of the bottom half of the vessel has some sort of pitting damage. So in order to try to minimize the cost of more detailed inspection, engineering evaluation, we started by reducing the MAWP of the vessel as much as we could. So we worked with our operations team, found out we could reduce it by 50 PSI. And then we also re-rated to the current code allowable. So it gained us quite a bit of additional corrosion allowance. So that minimized the extent of the level 1 and level 2 assessments that needed to occur. So then the next step, we worked with their inspection group and provided level 1 assessment guidelines for them to completely inspect the vessel for any pitting damage that had eaten into that additional corrosion allowance we created. So in doing that assessment, they came back with everything meeting the acceptance criteria. You can see on the bottom left that chart, with one exception. There was a LTA that did not quite meet that acceptance criteria. So we performed a level 2 on that, which required a little bit of additional inspection. And then additional engineering evaluation found that LTA number 15 was also acceptable as is. So since the damage was due to CUI, we could coat that vessel, and then it wasn't necessary to be insulated in the first place. So the client did not go back and insulate it. We were able to eliminate that potential future damage and run it as is. So that one didn't require any type of shutdown with minimal cost of repair, since it just required a coating. This third example is a proactive approach. So this is the brittle fracture assessment. On this one, the client came to us with a shell and tube exchanger. They weren't concerned necessarily with where they operate this exchanger, but they had planned some maintenance activities that could occur in the Alaska environment. So they wanted to understand what the true MDMT is for this current code. So we did a level 1 assessment for them. Found that the shell side of the exchanger was limited to 62 degree Fahrenheit MDMT. So this environment, that's not acceptable. So we conducted a level 2 assessment and developed a critical temperature curve. So on the left, you can see the one for the shell and one for the channel, and that's basically just a pressure versus temperature curve showing the allowable operating zone. And they were able to use these curves to update their standard operating procedures, both for startup and for the maintenance activities, including cleaning exchangers. In this final example, this is a level 3 FEA assessment example. This particular one is for a large diameter tower, and the client had identified shell distortion by using a laser scan, actually, and they could tell that there was up to 2 inches of deformation in portions of the vessel. So that's well out of the tolerance of a level 1 out of roundness assessment. So we decided to move on with a level 3 assessment. Part of that was coordinating with their inspection group to provide additional UT thicknesses, additional hardness testing to verify the material, and then temperature scanning that could be input into the FEA model. And we actually used their laser scan data to help model the geometry in ANSYS to complete the FEA. Then evaluated it to protect against plastic collapse, local failure, buckling, and ratcheting. And in this case, the plastic collapse was the controlling mode of failure. So using that case, they ran a couple iterations to try and figure out what the future corrosion allowance was. In this case, it was pretty minimal, just the 32nd of an inch of corrosion allowance. That was acceptable, deemed acceptable by the client. And we just recommend that they further inspected the welt in the area to make sure there are any indications there, and then continue in-service monitoring thickness to monitor the corrosion rate and for any other deformation or temperature hotspots that weren't used in the FEA model. So in summary, operating equipment with flaws or damage can be done safely as long as an assessment is performed for standardized rules such as API 579 to determine that is acceptable, and Anvil can assist you with this process. Are there any questions on this presentation or anything else that mechanical services that Anvil provides?
I have one or two. Is this a good tool to support or establish a risk-based inspection interval program, or even complement a mechanical integrity program?
I think it can be used definitely with a risk-based inspection program. You can use it to kind of understand how much a piece of equipment or a portion of a piece of equipment can tolerate damage, and then you can concentrate your inspections on the right spot of the vessel instead of doing a global inspection.
No, I appreciate that, the report you produced on our overhead vessel, the repair plan and, as well as the assessment. That's been very helpful in terms of extending the line out, so.
Yeah, it was very, very similar to that first example, same type of approach there. Trying to get you guys to a planned shutdown and then repair and eliminate that future damage rate, or at least control it.
What would be some other tools you could use besides just doing an API, fitness for service? You know, are there other parts of the code that give you more flexibility, like say maybe Div 2 calculations or something like that?
Yeah, so like along those lines, I think the level 3 part of API 579 is very similar to a Div 2 vessel. They use the same type of approach. So it'll definitely, that level 3 is more rigorous and it really dials in and is precise. Also comes at additional inspection requirements because you have to have that very dialed in on your FEA. So additional costs and time.
In your opinion, though, that's probably a lot cheaper than an unscheduled shutdown.
I would think it would be, yes, depending on the piece of equipment, of course. I think that's part of the kind of the process of moving through the levels. At some point, it may be more cost effective to just go ahead and repair, and you gotta coordinate with the owner user and communicate that, so don't end up going too far and then having to do a repair anyway.